Coming up on Dr. Kiki Science Hour, we're talking about astrobiology and life in the universe with Dr. Chris Impey from University of Arizona. That's up next on Dr. Kiki Science Hour.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Dr. Kiki's Science Hour is provided by CacheFly at CACHEFLY.com.
This is Dr. Kiki's Science Hour with Dr. Kiki Sanford, episode number 79, recorded on Thursday, January 13th, 2011, talking about life. This episode of Dr. Kiki's Science Hour is brought to you by MailRoute.com. Businesses of every size use MailRoute, from 1 employee to 50,000. It doesn't matter. MailRoute will protect you from spam and viruses, simplify your life, and make your email usable again. Go to mailroute.info for information. Welcome, everyone, to another episode of Dr. Kiki's Science Hour. I'm Dr. Kiki. This is episode number 79, and I hope you're ready to get down and dirty. We're going to spend an entire episode talking about one of the biggest questions in science. Are we alone? Is there other life besides the life that we've found here on our own planet out there in the universe? This search for life, the study of life in the universe, also known as astrobiology, is a fascinating and growing topic in the sciences. And with us to talk about it today is Dr. Chris Impey. He is a distinguished professor at the University of Arizona, deputy head of the Department of Astronomy, in charge of all academic programs. So you're the one he's the one that you're going to talk to if you're going to that university and you have an issue with one of the academic classes there dealing with astronomy. His research interests are observational cosmology, gravitational lensing, and the evolution and structure of galaxies. He has 160 refereed publications and 60 conference proceedings, and his work has been supported by millions of dollars in grants from NASA and the NSF. Chris, you've been a very busy person. As a professor, he's won teaching awards. He's been involved in developing curriculum and instructional technology. He's also past vice president of the American Astronomical Society. He has also been an NSF Distinguished Teaching Scholar, a Phi Beta Kappa Visiting Scholar, and the Carnegie Council's Arizona Professor of the Year. Impey has written over 30 popular articles on cosmology and astrobiology and co-authored 2 introductory textbooks. His first popular book, The Living Cosmos, was published in 2007, and he also published How It Ends in 2010, which is an exploration of how everything from life to the universe come to an end. And most recently, he's compiled a book of conversations about life called Talking About Life. And so let's get started with that. Dr. Impey, would you please let us know how it was that you came to be interested in astrophysics, astronomy, and this search for life in the universe?
Well, astronomers usually start one of 2 ways. They either have little telescopes and trade up to bigger ones, or they get into it through physics. And since I grew up in Britain, where there are not too many stars visible, I didn't have small telescopes when I was growing up. So I got into it through physics. It just seemed that there were big questions that could be answered in astronomy, and they were still on the table, and you didn't need big research teams to do it. You could have an idea, go and make observations, and really learn something interesting. My research is the distant universe. Basically, if it's less than 1 billion light years away, I don't really care in my research. I'm being facetious, but it's nice to have a sideline, and the search for life in the universe is so hot, it's so exciting, it's so freewheeling, it's in its adventurous phase that I just sort of got swept into it as a bystander, as a commentator. I started going to the conferences and learning the funny handshakes and wearing the same silly hats that those people wear at their conferences. So I sort of got co-opted into that community and then started writing about it. And it's just a lot of fun. I like spreading my bets between the very distant universe and the nearby and potentially living universe.
And do you think, I mean, the comment that that you just made about the difference between the distant universe, it being so old, having been in evolution for billions and billions of years, whereas the nearby universe probably has been in existence for a much shorter period of time. What do you think the likelihood of where life would be found? Would it be nearby in this kind of neighborhood, or far away, billions of years ago?
I mean, the answer actually may be both. One of the exciting things to consider is, when was the first life in the universe? Stars have been making carbon and the elements that we think are necessary for life for billions of years. In fact, the first Earth-like planet might have been put in place less than a billion years after the Big Bang, which means there could be Earths out there that have a head start on our planet by 4, 5, or even 6 billion years. So that's a phenomenal prospect. So the span of time is enormous.
Yeah.
As far as the nearest life, that's also exciting, because as the estimates of the number of habitable planets go up, then by implication, the distance to the nearest one goes down. Many people are extremely excited by Proxima Centauri system, which could have which has two stars that orbit each other, but not so close as to disrupt terrestrial planets. And so we may have a double bet of Earths in the nearby universe within 4.5 light years. So that would be the best outcome of all.
Well, yeah, it depends on what we would end up finding there. Is it an Earth that we can maybe go colonize, or will there be other types of life forms there that might not be friendly to humans? That's one of those questions.
Right. And Stephen Hawking, of course, got some big media attention by essentially saying we don't really necessarily want to know the answer, because if they're intelligent, they might view us as superfluous, or as food, or as a potential, competitor for real estate in the galaxy. I think that pessimistic view, it's premature to have that perspective. And also the statistics indicate that the most likely life we find, and even the nearest life, will be microbial. And we don't need to be threatened by that, of course, unless some of it comes back to the Earth and we can't survive with it, since microbes are our enemies on Earth very often.
Our friends and our enemies. Sometimes I like to call them my frenemies.
Yes, that's right. And then we don't know which way it will go. Well, science fiction, of course, has had, back to War of the Worlds, has had fun with the idea that if we find microbial life, is it our friend, is it our enemy?
In terms of what we're going to find where, I mean, the first step is actually locating other planets, prospective planets for life, to where life might have evolved. They're with, the Kepler mission and others recently identifying, it's big in the news this week, a rocky planet that's very similar to Earth. I mean, you say rocky, it's similar to Earth. How similar is it? Do you know if these new planetary discoveries are upping the likelihood of finding life?
Kepler is a brilliantly designed mission, especially since it was crafted and designed really before the first extrasolar planets were found back in the late 80s. So it's come of age just at the time when we all want to know the answer. Kepler is designed to tell us the census of Earth-like planets, to basically say, for a typical sun-like star, what are the odds, what are the probability that it'll have an Earth-like planet? But with Kepler, we have to be patient. It's going to take 3 or 4 years before Kepler finds Earth-like planets in Earth-like orbits. So the planet that was in the news very recently is indeed an Earth-like mass, but it whizzes around its star in 20 days and has a surface temperature of 2,500 Kelvin. It's just absolutely sizzlingly hot and implausible for surface life. Yeah. So with Kepler will give us the answer, and we just have to be patient because Kepler's looking for the little dip in the light as the planet travels in front of its parent star, and for an Earth-like planet, that happens once a year. And to be sure that they've found what they think they find, they wait for 3 eclipses, so that takes 2 or 3 years. And so they will find Earth-like planets in hospitable regions or habitable zones, but probably not for a couple more years.
So we should be waiting for the news to come out down the road, possibly. For the I guess the extent of conditions that life could develop within. We have what we know to be suitable for Earth life here on Earth. And can you go over some of the I guess extremophiles are the organisms that have kind of opened up our understanding of the range of conditions. But
right.
Can you explain a little bit about extremophiles and how they've influenced the search for life?
Sure. One way of looking at it is that as people think extremophiles, these are microbial organisms that can subsist on toxic elements. In the news, of course, there's been the replacement of arsenic in some microbial organism where it survived quite well. So we think of them as oddballs and extreme, but in a sense, we're the oddballs because large creatures like ourselves can only exist in a very narrow range of temperatures and pressures, and we're the fragile organisms on this planet. We call them extremophiles, but extremophiles are just more robust and use more of the real estate of this planet. They occupy, volcanic terrain. They occupy places in the Atacama Desert where it doesn't rain for 100 years. So again, we always say life needs water, but it sure doesn't need much. Yeah. We say life needs carbon and all these other ingredients, but we've found you can swap out some of these ingredients. Back to the 1970s when entire ecosystems were found in total darkness on the seafloor at pressures of hundreds of atmospheres and superheated water temperatures. Nobody anticipated that. There's life found in deep rock, and we actually have a very poor idea of how much life is under the surface of the Earth in the top hundreds of meters. Some people estimate that the biomass of microbes that's under the surface is 10 times more than scrape up all the plants and animals on the surface. So extremophiles have radiated into every conceivable and some inconceivable ecological niche, and that sort of must be telling us something about life, because here we have a planet where we sort of occupy the temperate zones and we don't like it to be too hot or too cold or too anything, but biology is quite comfortable in the extremes. And the more general conclusion that we should draw from that is that biology on this planet, the only planet we know with biology, has of course been bounded by the physical conditions of this planet. Right. If we go to planets that have other ranges of physical conditions, we should not assume at all that life can't exist beyond the bounds of the range of this planet. And so we probably don't know what the bounds on biology really are.
Yeah, I guess there's someone in the chat room here who's asking how has the study of extremophiles affected our understanding of the Goldilocks zone. So the Goldilocks zone, for anyone who doesn't understand what that is the perfect range of conditions within which life can evolve.
And the simple answer to that question is that it's sort of blown it out of the water, because the Goldilocks zone or the habitable zone in its traditional formulation is the range of distances from a sun-like star where water can be liquid on the surface of a planet. And that's a narrow range, and the Earth sits in that range, and Venus and Mars in our solar system are beyond that range, and so beyond the habitable zone. But there are organisms on the Earth that can exist beyond the habitable zone. We have several locations in the outer solar system, the frigid outer solar system, Enceladus, Titan, Europa, at least 3 very hot prospects for microbial life that are way beyond the habitable zone. So even in our solar system, we know the habitable zone notion is probably wrong. All life needs, we think, at a minimum, is perhaps it needs carbon material. Let's assume it's carbon-based. It needs some form of a solvent, and that could be water, but it doesn't have to be, and it needs energy. But it doesn't need much energy, and that energy doesn't have to come from a star. So the whole idea that life needs a star is wrong. There could be free-floating planets in deep, frigid space where the energy comes from geological heating. You can imagine, this is where science fiction meets science, because some of the clever ideas of science fiction are still entirely plausible for life in the universe.
I love that concept. I read a lot of science fiction myself, and so in the ideas that are wrapped up in a lot of these novels that I read, it always comes back to, what do we know now, and what could actually be possible?